Okay, let's turn down this sound, this music. So, saying goodbye to SidPlay. Let me know also if the sound volume is enough. Right. So we're on. This is something else. So basically now there is one bug in the C3 compiler. It is essentially when you are detecting. Maybe I should pull this down. So let's see if I can grab the latest of the master. I think we had. Okay, right. So let's see. We have somewhere a what's that? What was that one called? Something about in out. So let's see here. That's not that one. Sub array. Let's see if we can find that test. Because I commented it out so recently. That was not it. Yeah. These are the ones. I had to comment these out because they didn't work. And the reason I had to make those not work is because the detection was too zealous. So if I grab this code, put this here in my working place. So if I grab this code here and then we write on main here, and then we maybe we need to have another one. So we need to have another like test one or something. And this one is also taken out. So we have a param, which is not param. And so let's make that one a something like that. And now we want to pass this. Maybe I should just reduce this a bit. But okay. Anyway, so if I want to pass this now to the test2 here, so we can say, okay, it's going to be in a null. That's allowed. And we want to take like out. Now this is no problem. No, actually, in one is bad, but you know, you can have something simple there. Oh, hang on, I need to let my cat in, or she'll just jump on everything. So in short, we want to detect that out here is, is correct. It's matching this. This is an out data. This is an in data. So I could just put like param in and in data like that, right? So let's say I did this. That should be an error. So let's just run this so you can see that it doesn't work, or parts of it doesn't work anyway. Okay, test. What the heck did I call this? Test. Yeah. Right. Whatever. Right. Let's see. No one has said anything about the sound yet, so I presume it's reasonable. Okay. So okay, the definition here is like now parameter may not be passed into a function or macro as an in or in out argument. So that thing is okay, right? But we don't get these errors here that you should be getting. And so the reason why that happens is that what I did was something like, let's say I have a subset of this parameter. So we are getting like this part of out. I was saying, okay, we want to, get the output into that one. And if out is an out parameter, that should be possible, because we're actually not modifying it by doing this. But this stopped working. And so right now it works, but that's because these don't work. And there is a check, and I commented that one out. So it's in Sema R value something. Let's see here. R value, cost R value. There we go. So this is going like, if something is turned into an R value, that means it should be loaded. So that's basically what it should mean. But if you look at, so that's true. Like if you have let me show you here instead. So let's say we have a slice, right? Then if I do something like, take that element of a slice, and that's a load, right? This is a load. That's a clear load. But what happens if I like do this instead? This just creates a new slice. But we get this kind of thing where we have, so we get something like, hang on, what's that? So we have this case, right? But we can get, I don't know, we can have like another variable. Again, it has like this. And then you can do this kind of copy between them. So, or maybe the other way around. So if we have something like this, then that should be an error if X is marked out. So for example, up here, if you do something like yes, create something here, which is 1, 2, X, then this should be an error. So maybe 2 equals X. So this should always be an error because of how it works. Right? Because it's an out. Oh, no, sorry, that the other way around, of course. So in this case, should always be an error. In this case, we would say that this is an R value. But like if we then, on the other hand, if so this one, if we do this, this is not okay, but this is okay. So like as I've been looking at this, maybe I was thinking like, oh, maybe I need to rewrite a lot of stuff in the expression handling, but let's see if we can just patch it for now. Because it would be nice to kind of have this working early, and after it's actually really working, I would really start fixing this. So it's like kind of a longer, longer refactoring, right? Let's see if, anyways, okay. So let's go. What I can do is I can start by, re-enabling this thing that doesn't work straight away like this, right? So here we are looking at like, okay, if it's a slice or an expression, we are we are doing this check. But then one might say that, okay, if it's let's see, if it's a subscript, if we just ignore it for this one, right? So in this case, we are just saying, okay, that's fine. And then just for, sorry, the other way around. So in the subscript case, we are saying, okay, we have to do this. So then we don't need this particular thing, because it's just going to be like, because the subscript is more of a, if it's an address, it's going to be fine. So we have to check that as well. So let's see what happens if I enable this. So let's now work this. Okay, so look at this here. So the out parameters may not be read. Okay, so that's okay, correct, right? So, but we also get this in here. So let's see what that does. So the round key here is, okay, so actually here, this is wrong. There should be an in-out parameter here, because as you see, you're reading from it as well, right? So you start by generating it, but then you read from it and do stuff, and then you write back to it. So that was actually a bug. Right, and then now we just get to these, right? So we get only these. So we are getting that one, but not this one. And that might be reasonable because we are not reading that. So let's go back to that particular error. And then we're gonna, so which one was that? Again, let's jump back. We had it somewhere. That was not it. Where is it? There it is. So essentially, this one is okay, right? Because just grabbing that slice is not going to access the data. Okay, so let's run that. Okay, no, sorry, let's run all the tests. So now we're going to run the test cases, but I have a feeling that there might be something that we need to check, right? So I think we, failed, this one failed, and this one failed. So let's remove these, okay? And okay, let's stop those tests. It will take long. So let's see what else is breaking, right? So so actually it looks like this is passing, right? But look, we are taking that slice and assigning it to this, and that should not be allowed, right? This should definitely not be allowed. So again, we're gonna have to kind of go in and see when does that happen. Is there a way to kind of check whether that one was really when it's going to be like mutated or it's not. So if I put this code in there again, like separately, I'm just going to grab this and then not actually handle this, but I'm just going to do a breakpoint here. So now we're in here, right? And now this is not giving us an error, but it should, right? Oh wait, this is not that case. This is the case where it's just an expression, right? So let's continue, and we have this again, and now we see it's a slice assign, right? And now we should really be looking at whatever what pointer is below here. Is the slice assign, and the right hand expression is a slice. Otherwise it's a slice like what's this? Can it assign a slicing operation with yeah, of course. Now, so let's see here. This one goes down here and then goes to slice copy. So this I think is like a slice to a slice. And this is the assign everything to a single value to that slice, and this is the part where you actually have a copy. And look, you are analyzing the right hand side again, like you already did it here, so why are you doing it again? Then you do it there. Is there any place where that isn't, find usages of that slice, copy. Why can't I look at the usages? Go to run. There is just this one, and then we already had a analysis of this, so this shouldn't possibly be needed. So what does it do? It's just going to cost an R value, and I think we already did that. It does do a bunch of other things, I guess. But actually we can, set in here. We do the cast R value, right? And we say, okay, mute. I don't know what mutate means. I don't remember this one. It's like when I see this, I get annoyed because hang on, it's okay, so it's just like if I have if I set mutate, it's going to collapse the identifiers. Otherwise, it's like a left-hand side. I don't remember. I don't know. I don't know, man. This is weird. When doesn't it mutate? It's like here. Oh yeah. Okay. So when it's if it's this is really like when you do a constant and you don't want to fold it because you're doing an op assign, which is basically like a copy of a temporary stuff like it's like you want to have it on the left hand side and right. Bad. And it's used like for a lot of stuff. It's almost always true. It's just this case is like it's I mean, you should really have something else there instead of having this mutate. And anyway, so once we are here and we know it's like the right hand side, it's like also okay. Anyway, let me not get in this case. If it's the expression is a slice, kind is oops. Did you see that? Like my CLine does that. It kind of like wants to. Sometimes you want to, it randomly complete something completely different and just inserts random code. It's great. So we have to do like our deferred kind of slice checking here, because now we know it's on the right hand side. Actually, I guess the all this tracking could have been done on the right hand side, right? On this code. Let's see here. So here's something. This one is doing the arc cast. If you're running analysis on a random expression, then I guess it's just going to cause it to an R value by default. Inferred expressions. I'm not sure that this will work, but it will work in this particular case. So, and now we pull out that code. This is like looks really awful right now. To be honest, this looks awful. Let me just fix this stuff, and of course, let's. I mean, there are reasons why this is bad, but it's not maybe not obviously here, but it's bad. Okay, so we have the right hand side, blah blah blah, and your fills and calls, blah blah blah, and then we do it here. Okay, so we get the slice expression. And if it's not one, so now we don't have a switch to jump out of. Okay, yeah. Leave those angry comments there. Yeah, that works. Okay, don't do this code at home, kids. Right. So now it essentially grabs that and does the checking in there. Let's see if someone has an opinion on here. So time to put in a comment. I'm not sure what that was. I missed that. I just saw that now. So let's see here. Okay, so oh no. Okay, so out may not be read. That's correct, right? But then we have this. Okay, an out parameter may not be read, but look, it's here, and that's perfectly fine. So it's not supposed to be here. I thought that was the only place, but it's not. So right hand side is used also for somewhat annoying. It's used for recalls as well, so can't use it there. So in other, I wonder though what happens. Like, okay, yeah, it's like a right. It's the second check there. I remember. So okay, let's go back to whatever that was. So we had this call somewhere, blah, in this right hand side. Subscript, no. Open sign. So as you see, this is like not scaling well. And I'll talk about that in a second, why this is the way it is, and why it's bad. Okay, so let's drop this one, right? And just do it exactly on the slice assign. Slice copy. Yeah, so slice copy. There you go. So if we are here with slice copy, then we can, start looking at the right hand side. So oops. So we want to have the right hand side, blah blah blah, and this there. Now this is not correct, not quite correct, and I'll show you why in a second. But this is the way that like the code has been, so I'm just going to leave it as is. So now we got this error. This is the only error now. And so we're kind of done, but let's see what happens. Like if I take that and then I want to slice it again, what happens then? So I think that will just make it pause or something. Yeah, look at that. So this is why this is broken. Okay, so I'll work on that after this. I'm just going to, kind of fix this bug. So rather than having that bug that kind of non-detection. I'll make sure that that at least works. So let's see what we had. It was called something like this. I should be able to find that particular test. If I didn't, yeah, so it's here. So we're going to remove, this one because it's no longer an error, but we're going to keep the other ones, right? So these are actually fine. So we can also get like one more, which is like if I take out data, and I'm just going to take out data on the other side, that should be an error as well. So I'm just going to have a dummy error here, and then I'm going to run this. So meanwhile, I'm going to talk about a bit about the compiler design. I'm going to answer any questions if you have some. So what feature are you working on and fixing? So it's right now working on the detection of in-out parameters. So if you have a pointer, basically you can think of it as like const tracking or something, right? So in this case, the slice is an out parameter. You should only be able to assign to it, and you should track that through a slice as well. So I can like show you the cases here. So if we have something like like the in parameter. So this is like a typical thing. So I have in might be a pointer, something like that. So in this case, okay, there we go. We found that error there. So let's get paste it up here. Okay, so what I want to track now is that something like this gives an error. That's an error, but not this. It's going to be fine, right? And conversely, something like this is going to be an error, but I mean this is fine, right? And something like this is fine as well. So out. So this is fine as well because they are out parameters. So that's the tracking, and ideally we would like to tag this variable. When you do something like this, I would like to tag this pointer that we got as being also an out parameter. So you can't do taking that and later do something like that. That should be disallowed as well. So this not just that one. So I hope that explains what I'm trying to do. And I think like a more general problem that I have in the compiler is not that. It's if you look at something more complex, like you have you have this, and then you want to go like, what happens when you do something like this is like now this thing is an L value, so that means it will basically want to turn this part here, this one is going to be like turned into the first get the address. It's like a slice, yeah. So let's do it like this, so it's easier. So we have 3 or 33 or 35, right? So first you want to turn that into a pointer. So you have like this one is grabbing a pointer, and then after that you're going to take this variable and index it with 2. So now you have like a new sorry, it's 33, 23. So, and then you want to like take this pointer and kind of turn it into this kind of pointer. right? So this is temp2, and then you want to index this temp2 with 2, right? But you want to take the address of it, so you want to do like, again, basically this, right? So temp3 is this, and then after that you are converting that one into temp4, which is like is temp3, and then finally you're indexing that temp4 and with 1 like this, and then actually you do like this, temp5 int, and then sorry, no, forgot that one, and then finally you do this is 1 2 3. So it's kind of doing this transition between things, like, and when you look at like these steps, this step and this step is something that C does implicitly. So C doesn't care. C does would just not think about those parts, but actually what happens is these steps actually happen, right? So when you want to model this, you want to model this in a way that you can then cogen nicely, but you also want to retain like more information about what's happening. So and so this is the cogen, right? So this is the cogen when you're talking about the L value. But if you instead want to have like int x equals 1 2, then it's much easier, because then you just like do this, like essentially you do so the temp2 is equal to so this one goes that way, right? So you take the address of y, and then you get, again, actually you don't need to do that. You can like immediately just grab this pointer for various reasons. So you can grab this, no, sorry, I did this one other way around, right? So yeah, thank you, confusing you there. So you grab this one, and now you have this part, and then again you take like, sorry, I'm reusing the temp, so, and then you can just take that temp2, and then you can index that one, and now you're done, because you never need to worry about the addresses. And the reason why this kind of doesn't really like, why they aren't really equivalent, is that you also get stuff like overloading. So that means if you do see something like this, some other foo 1 2 equals 3, then that one might be like foo get ref 2 get ref 1, or like set get ref 1 set 2 comma 3. That's like the code you want to generate. That means you need to know here, like you need to know this is what you want, and you don't want like this should be preferred over this code, which is also possible, so DAO overload is also possible, but you want the other one. So things get kind of gnarly because you need to know like where am I going to do, like when am I coming close to the assignment. And the way to do this, let me check this in. So restore some out checking. So the way to handle this is really breaking it down into different instructions, because the way I see this from this part, from a this one, from a compiler's point of view, is like I see on one side we have like, you know, subscript, script, and then, you know, of a subscript of identifier y, right? And then we have like the first subscript there, and then end and 2, and then equals, you know, number, right? This is how it looks like when it's parsed in the AST. And then you look at the other one, which is like the other way around. It's like a declare int comma x comma, and then you get like the same thing here, right? So these are the two things, and as you see, these are the same, right? So when I handle this, how does it know it's an L value or R value? So then it comes down, like points down to calling them differently. But the idea I have is that previous to actually, like before I start handling this, what I should do is I should rewrite this into L subscript, L ref subscript, and then identifier y, or it's actually address identifier y, and so on. So I think I added one more. Okay, so like this. So now it's distinct from this one. And then suddenly things are already kind of decomposable in this way, so it can know this rather than trying to jump back and forth and try and figure it out. That was lengthy explanation. Were people interested in hearing about that? I guess let me know in the chat. Okay, so let's see what we can do about that. I'm going to let's look at this. So as we see here, there's like a slice copy, and now it's going to do this test. But we are going to step back a bit, and we're going to look at what is called as a right hand. You know, the right hand, blah blah blah. We have the left hand actually. We're going to have look at the SEMA left L value, right? So here we go and have the analyze L value, right? And my goal now, maybe I shouldn't, maybe I should, postpone this to some other time. But what I want to do is basically, you see, like some of these, if you go from L value here, so I go here, and then you're going to see like L value dispatch is going to like do special stuff here. So here's like okay, this normal identifier, yeah, it's going to be normally handling that, but here it's going to be like just jump it to L value, and there's this actually kind of a jumping through another context, which is happening with the macros. But and again here like there are some fixes. So basically, instead of analyzing it, I was thinking of like, let's go and tag them differently. So you go through the L values and then you start tagging them differently here. There is this issue with folding the hash identifier here, which I think you need to do. Because it's just going to replace stuff. But definitely the subscript L value will be able to create a new expression. These, could just error out there. So they never happen. And then these are just left as is, I think. Right? And then we have some checks here, I guess. Which can then be, here's an L value dispatch. So all of these expression dispatches, those are just skipped. But I'm thinking like maybe maybe you should just do recursively go and do the L value dispatch on things and can see how far down it needs to change things. So now I've been talking for about like 45 so 40 minutes, right? So maybe I should leave it like this, or kind of have a way forward before we analyze something in as an L value. And I think that's a fairly okay, so it's the recursive one, sorry. So we do just doing it here as an up assign. We do it on the inc deck, right? Because when you want to increment and decrement something, you want to have it null value. Concat assign, which is a new one. Then all assign operators will have it left side analyze as an L value, so transformed into that L value. But there's also, a problem with that. Like, so maybe it works. You first say this has to be an L value, and then at one point it will turn that L value into an R value, and then you're kind of able to do that. So I'll have to look at the consequences of this. But like looking at in normal cases when you have a simple when you have a fairly simple model, you don't have to care about this. You just need to there's an assignment, and just that's one thing. And also, if you don't have things like assignment expressions, then this kind of isn't such a big deal. So we can see that the L value thing here, if you see this, look like 1, 2, 3, 4, 5, 1, 4, 6, 7 places, right? And here's like one handling because of its constant identifier. We have the normal assign, right? And then we have this op assign. Again, that's a special thing. Inc deck, and a lot of languages doesn't have that even. And then the concat assign, again, meta programming. And then the binary, again, op as assignment expression. And then one recursive thing here with the, again, meta programming. So most of the time you don't really need to do anything special with this, but it just happens that the semantics is a bit complicated in C languages, I guess. So what you often get, like, you can pass things around as an address in a lot of cases, and then you load from that. So your variable is just this address that you pass around, and that it kind of falls out in a fairly trivial way to kind of implement this and lower this if you're not concerned about more advanced features that came later in C. So and optimizations. So this way it like becomes a little complex. And there's another like issue. There's actually an interesting thing in relation to I just gonna pull this one out here and you'll see. So we have something else, and this is actually related. So if we have this instead, and now this is not related to in-out, but it's semi-related to things. So in this case, we have a flexible array member at the end. And here we tried to clear that, but it doesn't have any length. That's just the way it is. And you're able to kind of allocate that one on the stack like this. And then it's assumed that this one is just 0. So that's what happens. And you can, in C, you can do this. So you can have this, like the own string here, S, and you can already like have 2 here, like, and then, the data here. Let me just clarify this. So length is 2, and then the data is going to be like this. So this is quite valid and actually works in GCC and so on. What's interesting is that in Clang this works, but it doesn't work in GCC. Anyway, what you can see there is that basically it will allocate this extra memory, and you can then kind of handle that. But the problem is, if you look at this and then you want to see like, can you set this field or not? Then you have to know here, when you are analyzing this initializer list, that now we're assigning to a global. So this kind of thing here is it's kind of annoying for the compiler to I mean, usually it would just look at, okay, the type is own string, then can I assign this to this own string? But you can never do this. Like, I can't write this would never be okay. Like having this and then saying that, because now this would overwrite memory, because I just allocated enough memory for the first one. So this one is trying to write more data than is available here. So that would be like bad. So that's why this is never allowed, really. But if we grabbed a pointer to this, theoretically this could be allowed, because maybe someone took this and then did a malloc for like the size of own string plus 2, right? And then suddenly this would be fine, because it would not actually overwrite in data, because you had enough space, right? So the question here is like, okay, some of this might not be allowed, right? What do you allow and how do you communicate? Basically, okay, here we're assigning to a pointer, so I have to kind of move that knowledge in here. Yeah, because the type is not saying what, like not determining what what is okay for this one. So it's a similar issue with communicating between the left hand side and the right hand side. Okay, I don't know. Right. Okay, yeah. Not sure I got it completed, but it's interesting to see the inside of a compiler dev. Too much of a web dev Android to quite follow it completely. Okay, that's fine. I mean, you can't really follow a compiler until you really put put some work into working on it. But then it kind of falls into place. But I still find some. I mean, I can look at Clang, and it's still you have to kind of hunt for where does this thing, where do things actually happen. And hi to Lowbyte Fox who joined. So that was that. This is this is a gnarly thing because I didn't really decide on what semantics could be. I could like just, do a cop out and then say, okay, no, you can't even do this. But this is actually very useful. This makes sense. You want to create these, and then like if you can create that one, then it kind of makes sense that you want to zero it out. But you can't. I mean, you can't reasonably do, this one, because how do you know from the own string how long that data is? So you can't really do this. So it has to prevent this. However, something like, oh, okay, let's clear those 2 bytes. That should be possible. And so, yeah, I think this works. Let me just check that. That would be interesting. So I know this actually works, this part. So you can, let me just run this. So this should be fine, but maybe it isn't. So. Oh, this is going to overwrite memory, by the way. It was, but it was okay with that. So okay, let's do like data. Okay, and then we're gonna print this. We take the data at the end, so let's take as data, like that, and then convert it to a string. Then that should be okay, and when I do it should be kind of empty, right? Maybe I could just do like that. Okay, let's see, that looks right, except I didn't import std.io. Ooh, okay, yeah, I couldn't do this anymore. I couldn't do that. That's true. Damn it. Then you just have to malloc. How much do I need? I don't care. So then we can set like s is slan is 2 and s data 2 should be okay. This should be okay. Why is it there? Okay, so just making sure that this trivial stuff works. Right. Boom, yeah, that works. Yeah. I would be surprised if it didn't, because this is like the basic uses of it. Okay. While I'm on it, let's see if there is some other bug I should fix. It's just the ASM bug, so we still need to kind of decide on what to do with those. Should I like briefly go through the issues, by the way? Let me see if I can grab the screen here. So I need another screen. So what should that be? It should be a window capture, and I want to see one of the Safari. Okay, Safari issues. Okay. Okay, you have to bear with me. This is bright, right? And turn it. Like, can you see it? No, it was behind everything. All right, all right. So the bug that we discussed was um, this one, right? So compiler cert when assigned to type, however. So I can trivially fix that, but there's a lot of discussion here. So if anyone is want to weigh in on what should be possible and what shouldn't be possible, let me know. This is already fixed, and this is like should we keep the git keep, but I think like yeah, let's close this for now. Okay, no need to have a lot of things that are kind of confusing. So we have the ASM thing, implement unpacking on via list, right? So I've already done as part of that, right? Support outputting, oh, Termux. I don't have this. I really need some people to work on this, really. Um, there is stuff. Libc, the weak thing is interesting. I need to think about this a bit. Oh, and the Nix thing. God damn it. So the Nix was like you have this unacceptable. Okay. Add generics in inference. Actually, I already did this. So it was in there. That actually is not loose idea. It's accepted. Assign myself, and then we close this one. Right. Is there anything else? Let's look for bugs. Right. Sometimes memory. It's because the memory was never implemented, and I didn't do those. Those are. This is the weak. Oh, the definition. Oh, the grammar. Grammar needs to be fixed. Yeah, and this is wasn't this like crazy? Like, oh no, this was something else. I no. Yeah, I didn't have anything there. So okay. So no. Yeah, there are some things here. It's interesting, somewhat interesting to get that better. But yeah, okay. I shouldn't linger. That was. Anyone has anything they want to ask about or want me to look at? Here's like the chance. You have a chance now. Otherwise, just close close the shop. So, let me turn off that other window wherever it is. Right. Nope. There we go. Okay. So, hope you enjoyed watching that. A bit of hacking, actually, this, but I think like the next step would be to look at this L value dispatch and kind of change the code to reflect that, so we can finally have like one SEMA analyzed expression, and like that's it, nothing more. So and then we can also like that. There's one this like cost R value, like rather than doing the cost R value, that should also be like something that you that you add to the end. Because like if you have something, you just want to cast it to an R value when you really want it to be an R value, which is not always early. But now, no, like this check type. I need to get rid of that one as well. I want everything to just go through analyze expression. So right now, this is fine. I mean, this is analyzing special things. But what you have, like, oh, by the way, like, it's just going to say one thing. Like, imagine this wasn't C, and people were using people were using visitors to actually write this code and do the same thing, right? So instead of seeing or like cast R value, what that did, like here you can see exactly what it does, right? So you can see that, okay, that one is handling it in that way, maybe we can merge these and so on. Oh, now it's no longer needed and so on. Rather than having that, I would have to look at every single overload for that cast R value. And like that is what people are advocating. That is so funny. And like they're saying, like, you need to have this, otherwise you can't write a compiler reasonably. And here I can see like where does things get weird and what do I need to change? Like okay, we do something like let's scroll down. Like here we have the L value dispatch. We can see like which ones are like dependent on that, which are not. You know, which one doesn't care or go deeper. And I can see that directly here because everything, like, I don't have to jump anywhere, it's just here. And that's like it's not about performance, it's about being able to see like very concisely what the rules are, because these are the rules, right? Here we have like, well, giving an L value, right? These are the rules. Like if you have an hash ident, you're going to fold it. If you have a C identifier, you're going to resolve it. Just resolve it and don't do anything. If you have a subscript, you're going to have like analyze it as an L value. If you have another context, you're going to switch to state, and then you're going to do this like L value dispatch on that. You can like see that exactly what's happening right here. Like if you have this is like this is like when you write the spec, you actually write like this, right? And people are seriously advocating, like, rather than having it collected in a single place, let's put it everywhere. So like imagine you have a specification, but specification of like how to do something is like in under the headline of subscript, other contexts. Each of those have all the different things that they are like the rules for all of like what they do in different cases. So if you're going to implement something, you have to look through every one of those. In a lot of cases, they don't do anything special. So they're just a subset that actually does anything. And people are actually advocating that and saying like you can't write code compilers if you don't have that. I mean, that's the thing they want. It's insane. Anyway, with those, final words, I'm going to say good night and thank you for watching.